So, welcome everybody. Here we're running a short workshop on humanoid robots, sponsored by National Taiwan Normal University. The reason is that every year we get quite a few inquiries from teams that would like to join the FIRA Eurocup competition. And it's quite a steep step up from nothing to build your first humanoid robot. So with this series of workshop that we'll be running on Wednesday for the next couple of weeks, we will try and provide a background and some options for the teams that are interested in building a humanoid robot. And we'll also be looking at one of our NTNU junior students and see how she's progressing with building her own humanoid robot based on a kit actually. So as far as introductions is concerned, my name is Jackie Baltis. I'm a professor at National Taiwan Normal University here in the Department of Electrical Engineering, and I've been in Taiwan for 3 years. Before that, I was at the University of Manitoba in Winnipeg, Canada, and before that, University of Auckland in New Zealand. My co-presenter is
I'm Jae-sik Jung from South Korea. I am PhD student at NTNU. My professor is Jackie Baltes.
so you had no choice, you had to do the workshop.
Okay.
And what's your experience with robots?
I have participated in autonomous humanoid robot competition like RoboCup, FIRA Eurocup, and IROS HAC.
Mhm.
And I like humanoid robot, and actually I worked in automotive company in Korea during 3 years. I like ADAS system also. Uh-huh.
Okay, very good. Chrisman, you can introduce yourself quickly.
Yeah.
Hello everyone, I'm Didainu. I'm a student of Professor Jackie Baltis. I'm doing my master here in Taiwan and I am Brazilian. I did my bachelor in computer engineering and I also have some experience with robotics. I have participated in Eurocup, in Iran, in South Korea, and in Taiwan as well. Yeah, so mostly now I work with humanoid robots, focusing on vision and manipulation tasks.
Okay. And Jill?
My name is Jill. And then,
Yeah.
Uh-huh.
And you're the youngest member of the NTNU team?
Yeah, not now. Not like youngest.
Okay.
There
Oh,
was
'cause you
8
grew up.
years old when I was
Oh, okay. Okay. And how old are you now?
11,
11? Okay. And where do you live?
Taiwan.
Taiwan? Okay. And how long have you been taking part in FIRA competitions?
2 years.
2 years.
So yeah, almost as much experience as me.
Yeah. Okay, good. So thanks. And Jehan, where's Jehan?
I don't know.
Other room.
Mhm.
Okay. Jehan should come here quickly and introduce herself too. But I'll go and get her. And so first we start with a little presentation that we prepared to show you the landscape of humanoid robots. The whole thing really started because some of the inquiries that we got was we would like to build the humanoid robot from scratch ourselves, but we do not want to spend more than $300 in order to build the robot. And now we'll show you what these humanoid robots actually cost, the different choices that they are. As you will see, we can then discuss about what the money can actually buy you for $300, $1,500, and $10,000, I guess. So JSIC will start.
Okay. Change overview to PowerPoint.
Jackie, there's your other students.
Okay. You can come in, sit down. And
Okay. Change overview.
Everyone.
Yeah. Okay. Yeah, you can put down there. And then we'll do a second round of introduction. You can start with the PowerPoint.
Okay.
Oh, it's okay.
Okay. Start.
Okay.
Okay. Good afternoon. I'm Jae-sik Jung. Okay. I have participated in a lot of humanoid robot competition, like FIRA Hero Cup, IROS HAC, and Robot Cup. Today I will give some talk about how to build humanoid robot. Okay, let's start. Before explaining how to build humanoid robot, I will introduce some humanoid robot competitions you can join. There are a lot of robot competitions in the world. I will discuss famous humanoid robot competition with you. I will present autonomous humanoid competitions. FIRA has many categories like FIRA Sports Air and Youth, something like this. There are two humanoid leagues in FIRA competition. One is Eurocup, the other is Androsuit. Eurocup is like Olympic. Eurocup has 10 events such as sprint, marathon, obstacle run, weightlifting, basketball, soccer, archery, triple jump, mini DRC, and Spartan race. One team can use only one robot for this event. Okay. And also this autonomous soccer playing. Second competition. Yeah. And second competition is RoboCup. RoboCup also has many leagues like at home, rescue, soccer, industrial, and junior. There are also two humanoid leagues in RoboCup Soccer League. One is humanoid league, the other is standard platform. And third competition is IROS HAC. HAC mean Humanoid Robot Application Challenge. IROS HAC started Robot Magic Show from 2016. Judges evaluate participants with showmanship and technical skill. And next, I think most of you know Robo One. Robo One is the robot fight competition. There are three humanoid competitions such as Robo 1, Robo 1 Light, and Robo 1 Auto. Robo 1 Auto is autonomous robot competition. Others are remote control competitions. The last competition I explained is robot games. Actually, I didn't join this competition. When I checked website, this competition include Robo 1 and FIRA Hero Cup. If you build or buy humanoid robot, you can participate in a lot of competitions in the world. Okay, next. Next, for participating in a autonomous intelligent humanoid competition, we have to know humanoid robot first. I think we have four methods to join the intelligent competitions. First way is buying good quality intelligent humanoid robot like Darwin OP and now. This is the easiest way to join the competition, but these robots are very expensive, more than 10,000 USD. A second method is buying remote control humanoid robot and adding SBC and a camera module. This is cheaper than the first one. The famous remote control humanoid robots in the world are Bioloid and KHR3, and you can find very cheap Chinese humanoid robot on AliExpress or Alibaba. But the quality is not good, I think. SBC is a single board computer like Raspberry Pi, Odroid, RockPi, Banana Pi, Orange Pi, Tinkerboard, and so on. If you use SBC and you want to join intelligent humanoid robot competition, you need a camera module to recognize object. But SBC use a Linux system, and for detecting object, we have to develop image processing. for this method, we need advanced programming like OpenCV and electrical engineering requirement. A third way is like second method, but this is easier than second method. This method is using remote control humanoid robot with intelligent camera module. These intelligent camera modules include built-in algorithms, so user can use it very easily. But to use it, you have to know electrical engineering, how to connect camera to robot. The last method is building humanoid robot from scratch. I will explain this four method from next slide.
Yeah.
First, I will explain good quality intelligent humanoid robots. If you have enough money and buy one of these robots, you can participate in intelligent robot competition very easily. Because these robots include everything for the competitions. These are intelligent humanoid robots. Intelligent humanoid robots.
Say again. What?
Someone turn on mic. Turn on Josephine. Josephine.
Okay.
Okay.
If it's feedback, just mute them.
Okay. The famous intelligent humanoid robot is Darwin OP. Darwin OP participated in RoboCup maybe 2010, and then they got first place in RoboCup Humanoid League kid size. And then a lot of developers bought this robot to develop their stuff. The Darwin OP is the height is 45 centimeter and weight is about 3 kg. It has 20 degree of freedoms. It has sensors such as camera and IMU, but the price is about 10,000 USD. This is very expensive. And then this robot is from Robotis company. The Robotis company developed second generation Darwin OP2. This use better CPU than previous one. This robot is also same price. And maybe 2018, Robotis made new humanoid robot Darwin OP3. This robot used new generation servo motors, dynamic cell X series. This is a little bit heavier than previous two humanoid robot, but this robot has a good CPU. The CPU is i3 CPU, and this robot also has camera and IMU. And this robot include loss system. So many developers use this robot to develop loss system. Then the last humanoid robot is now from SoftBank. RoboCup Standard League use only this robot, only now robot, and this robot also has camera module and IMU, but this robot has a gripper, so your robot can grip a pen or something like this, but this robot is more expensive than Darwin Office series. The price is 14,000 USD. If you have enough money, you can buy these robots, and you can participate in robot competition very easily. Next, I will introduce some low-cost intelligent humanoid robot, but the quality is not uh, not 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 bad, but not good. Uh, First one is in engineering kit. Robotics made this 1 year ago. Then this robot has a Raspberry Pi Zero and Raspberry Pi camera. So Raspberry Pi Zero is not good quality CPU, but you can find you can do image processing like color detection or edge detection, something like this. And this is very lightweight. Just price is just 1,700 USD. Then actually Bridgestone is very famous in Bridgestone was very famous in RoboCup competition before 2000 until 2010. Team Osaka used a Bridgestone robot. Team Osaka developed humanoid robot with Bridgestone, but after making Darwin OP, many users doesn't didn't use Bridgestone's humanoid robot. But Bridgestone developed a new humanoid robot in this year. The name is RoboBG. This is very light, just 1 kilogram, and this robot has Raspberry Pi 4 with a Pi camera. The price is 2,600. And next humanoid robot is mini robots humanoid robot. This robot has intelligent camera module without CPU. So if you buy this robot, your robot can just do color detection. So this robot price is just 1,600. The last humanoid robot is Alpha Mini from Ubitech. Actually, this Ubitech developed this robot uh, for service, home service. So I think if you buy this robot, you cannot participate in humanoid robot competition. Uh-huh. The price is 1,200 because this robot has only 14 degree of freedom in leg, just 4 actuators in each leg. Okay, next. This is very advanced humanoid robot in the world. These are very expensive, and these companies sell this robot. First robot is Solmang 3 from Robotis. This robot has a 29 degree of freedom, and second robot is DRC Hubo. Maybe many roboticists know this robot because DRC Hubo got first place in DARPA Robotics Challenge. And this robot has 32 degrees of freedom. You can buy this robot in Rainbow Robotics. Professor Juno O established this company maybe from 2010, I don't know. And then the last humanoid robot is Walker from Ubitech. Ubitech developed this robot with Tsinghua University. This robot has 28 degrees of freedom in legs, arms, and head, and you can change gripper or hands. So you can this robot has more than 28 degrees of freedom.
Okay. So now we will stop there quickly, and the main point is that there's basically 3 levels of humanoid robots that you can commercially buy. That are of interest to the robot competitions. The OP3 level, about 10,000 US dollars. The slightly cheaper $1,500 for a Robotis engineering kit or Robotis Bioloid, as they were called previously. And then you have about $300, $400. You have some very limited kind of humanoid robots, because obviously companies have to make trade-offs. Nobody can produce an OP3 robot with those specifications and then sell it for $1,000 because the company would go bankrupt very quickly. They would run out of money. So those are the three options that you have. As the query that we got was for 300 US dollars. There is some options, but you sort of have to realize that it's not going to be as capable a platform as OP3, especially not for the full Eurocup decathlon, all 10 events. So instead, if you are in a situation where you're just starting out with humanoid robots, then you don't have a lot of money, I think it would be smarter, it would be better to focus on one event in the FIRA Eurocup competition, like for example the sprint or the triple jump, and then do a good job there implementing the robot, learn something, and then hopefully you'll be able to get more funding in the future to improve your humanoid robot design. Unfortunately, for humanoid robots, there is really no chance to be able to add on later on. It's not like you can buy a OP3 now with just the legs and then add the arms sometimes in the future. You just can't buy add-ons. So you sort of have to focus on the height and the weight that you want, the number of degrees of freedom. But once you have decided on those, they are, in most cases, they are fixed. So there's really no upgrade path for these humanoid robots. What do you think, Jacek? As far as upgrading humanoid robots are concerned, I think those are the three levels sort of money that you have. About $300, about 1,500 US dollars, and about 10,000 US dollars. You may be able to shave off 5% or 10%, but those will be roughly the categories that you're talking about. Yeah, you need to look at the camera.
Actually, I didn't understand correctly.
Okay.
Uh-huh.
Never mind. But basically 3 levels of capabilities, like you had in your presentation.
You mean first one buying a good quality humanoid robot, and then a remote control with some camera module, and very cheap motors with just controller.
Yeah.
I think when I participated in Huroka for the first time, I didn't use a CPU level. I just used intelligent camera module from Korean company. They built CTS module. This is the name. So if I use this module, the module can detect color, and then the module send X, Y, and Z coordinate and size of object. Then using via UART communication, then my MCU processor get this data, and then my MCU decide next action. So if some teams doesn't have enough money, they can build a very cheap humanoid robot using RC servo motor, because nowadays Chinese company build support a very cheap RC servo motor, about just 9 USD or 10 USD for each motors. So if you buy actually humanoid need 16 or 18 degrees of freedom. In this case, you can buy 180 USD and buy MCU and camera module. I think you can build a humanoid robot in 300 USD. But in this case, your university has 3D printer, something like this, and then you should get a frame.
We'll get to 3D printing in the future. But I think
Uh-huh.
also when you started the Eurocup competition,
Uh-huh.
you didn't do all 10 events, right? You focused on sprint
Yeah,
and the
only-
running events first.
Yeah, right.
And I think that's a good approach, especially if you don't have a lot of funding.
Yeah.
It is better to do a good job in one event than doing not so good in many events, I would say.
I think
Yeah.
so.
Good. Then we move on to the next section.
Okay. Yeah. This is second method. We can use remote control humanoid robot with a single board computer and camera module. Okay, I will explain some remote control humanoid robot. The first one is a Bioloid Premium. Maybe many developers know this robot. This is not very cheap, but the cheap humanoid robot in the world. This robot is the price is just 1,200, and next humanoid robot is Bioloid GP. This robot use better actuator than Bioloid in legs. So this robot is faster and stronger than Bioloid. This robot price, the price of this robot is 2,200. And next is I already explained KHR3 from Kondo. Uh, Kondo is from Japanese company. This robot is this robot has 17 degrees of freedom, and the price is 1,600. The last remote control humanoid robot is Tiny Wave from Robolife. This robot also has same motor as Bioloid GP, but the price is more expensive than Bioloid GP because this robot performance is better than Bioloid GP, I think. Then I will explain some single board computer. No.
Okay, so right, yes, okay, go ahead with the single board computer. Actually, can we move to the motors first, because those are
Okay.
the really a big part of the cost.
You mean this?
Yeah.
Okay. Okay. I explain servo motor. I will explain two types of servo motor. One is RC servo motor. The other is a smart actuator. Smart actuator mean the motor has a controller inside. Okay. RC servo motor. We can control this motor using PWM or timer. For using band pulse
Pulse width modulation.
pulse with modulation. So the most famous RC servo motor is from high tech. Actually, when I was undergraduate student, I used only high tech motor, because at that time the, every I don't know, but in my case, every developer used only this motor for a small size humanoid robot. And then Kondo and Futaba are making some RC servo motor, and nowadays many Chinese companies support RC servo motor. If you go to AliExpress and you search RC servo motor, you can find this picture. The price is very low, or like 10 USD and 3 USD, 5 USD. But actually, I didn't use this servo motor. But when I asked someone who used this motor, they said this is not good. Sometimes if they give some pulse to the motor. In this case, a motor didn't work. Sometimes, yeah, like
So,
this.
switch the camera.
Okay.
So as far as the RC servos are concerned, those are the cheapest actuators you can get for your robot. They come in a huge range of price, use, huge different prices, huge range of the price for these RC servos. It depends on how much torque the servo can generate. The ones for $3 are have very low torque, which means that they're usually not powerful enough to hold up your humanoid robot. That makes it impossible to develop a walking gait simply because the servo is not strong enough. Another difference is whether they use plastic gears or metallic gears. Metallic gears are more sturdy. Often, when the humanoid robot walks and the foot hits the ground, the contact force, the contact shock, is sent directly through the servo into the gears, which means that if you use plastic gears, there's a good chance they will break. So for a humanoid robot, I think you really want to use metal gears or something better than the cheap plastic gears. But you can get them in a huge range of different sizes and weights and torques. But when we're thinking about developing a humanoid robot for $300, then even if the servo motor is only $10, like J6 said, you need to have 18 servo motors for a fully articulated humanoid robot. So that's already $180 that are gone just for the servo motors. And the other problem with these particular design is that you need to have an extra CPU in order to generate enough PWMs. Most embedded platforms can, like the Raspberry Pi, I think can generate 8 PWMs, something like that. A lot of them, if you run Linux, Linux is not a real-time operating system, but the control of these servo motors, if you do it via the CPU, it's very sensitive to the timing. DSIG will show you the PWM. So every millisecond counts. So if you have this kind of robot, you usually have a small embedded device with enough PWM channels that can generate these signals via hardware. And then only can you get reliable, consistent performance out of these servo motors. Okay? Next up, you can talk about the intelligent modules.
Okay. Next, I will explain smart servo motors. Dynamic cell is the most famous smart actuator in the world. In these categories, robotics made many kind of servo motors. The torque is from 1.5 Newton meter to 45 Newton meter. They made Dynamic Cell series, Dynamic Cell X series, Dynamic Cell Pro. The Pro is most the powerful, the most powerful motors, and but the motor is very expensive. The price is from 45 USD to 2,600 USD. And second picture is KRS and P3M series from Kondo. This motor also use robotics, dynamic cell, and this motor use TTL and RS485 to communicate with our controller. Kondo motor. Some Japanese team use this motor in RoboCup, and the price is from 20 USD to 30 USD. And the last motor from Bridgestone, this motor, this this company made only three type of smart actuator. This motor name is V servo motor, and torque is from 4 Newton meter to 32 Newton meter. This motor has only TTL interface, and the price is from 300 USD to 1,400 USD. So this motor has, I already explained you, this motor has one controller inside motor. So our main controller sent some protocol to this motor. Robotics support protocol 1 and 2 like this picture, and Kondo support one protocol like second picture.
Mm-hmm.
Then
Okay, good. Then we can stop there. So those are the two choices that you have. As you can see, with $300, you really cannot you cannot build your robot based on these smart actuator modules. Even though they have a lot of advantages, they make a lot of things easier. But the cheapest one I think that Robotics has is $45 for each motor. So you'd be looking at $900 just for the motors. And two things that are why the intelligent servo modules make building a humanoid robot, however, a lot easier. One is you don't have to worry about the real-time aspects of your system. They include a microcontroller that generates all the timing critical signals. Two, you can chain them together in a bus, which actually means that cabling the robot, running the cable from the center to the foot, the right foot, the left foot, the right arm, the left arm, becomes a lot easier because you just need to run one line rather than 7 or 8 lines. And actually, cabling a humanoid robot is one of the problems that most people underestimate. It's actually quite difficult to get the cabling done in such a way that any motion that the robot does doesn't tear or shear one of the cables. And often when our OP3 robot has problems, it's actually because one of the cables got unseated. For the RC servo, you have to bring every cable from the ankle, the knee, the hip 1, hip 2, all the way back to the central CPU. And the other advantage that these intelligent servo modules have is that they allow you to read back the position of the servo and the torque that the servo currently applies. The torque information is very coarse on the robotic servos at least, but it's better than nothing. But the RC servos, you really can only send a command telling the servo, go to this position, but you really cannot tell whether it actually got there. So if the robot is too heavy and the motor doesn't have enough torque to move it, then you may short circuit your controller board, you may burn out your controller board, and you would know that the robot hasn't reached the position that you want it to move to. So there's a lot of advantages to using the intelligent servo motor modules. However, given if you're looking at $300, those are outside of your budget. But I think if I were to use extra money, then I think I would spend it on good motors. That would be the first thing to do for a humanoid robot. Even if I have to buy a cheaper CPU, I think that would be better than not spending enough money on the motors. Now, Jill here actually is currently working on a small humanoid robot for about $300, and she's just calibrating the servo motors. So, Jill, you can show the servo motors to the camera to see what they actually look like. And then, if you can just give me that servo motor. Does it actually say what the torque is on here? SR1020 mg. I think you can just check the SR1020 mg and find out what torque it has. Just Google for it quickly. But you would think 1 or 2 kilogram per centimeter.
Maybe 3 kg.
Yeah.
Uh-huh.
Pull it out.
No, you just.
Okay, good.
Part name.
You can continue.
Yeah, this is part number. Enter. Oh, I don't know. What's the name?
SR1020 mg.
SR1020. 1020.
mg. TT robotic.
SR1020 mg. Oh, no. SR.
Mm-hmm.
Can you click there and show me?
There's pictures of it. Yeah.
Oh. Yeah. I see. This is same? No.
It's very.
No.
It has metal gear. It's probably a better
Ah,
one.
okay, yeah,
but,
better one. Yeah.
Does it say how much torque it has? It's low. For the OP3, they actually used the MX28 servos before, and now they use the XLs. And those are about $250 each for the intelligent robot module. So the OP3 has 20 degrees of freedom, 22 degrees of freedom.
20.
20.
Uh-huh.
So they use 20 motors. Each one of those motors is about $250, which is one of the things that people don't realize. They keep saying that, oh, I can 3D print the humanoid robot, which yes, you can do. That will reduce the cost of manufacturing the frame a little bit. But really, a huge cost is your servo motors. And they don't become any cheaper because you use 3D printing. You still have to get them somehow. Okay, good. Then next, once you have decided on a set of motors, you need to have the processing board for them.
Single board computer, or you want to show every like MCU, Arduino, and SBC.
I think you can just go through them very quickly.
Okay.
Yeah.
From here.
Yeah.
Okay. So my second method use remote control humanoid robot and with SBC and camera module. So I will show some single board computer. Maybe most of people know these SBC computers. First one is Raspberry Pi 4. This SBC has 1.5 gigahertz CPU, and you can select 1 gigabyte, 2 gigabyte, 4 gigabyte, and 8 gigabyte RAM. But this SBC support only SD card for storage. But Raspberry Pi has 3 type of networks. One is gigabit Ethernet. Another is dual band Wi-Fi, and The other is Bluetooth 5.0. And the price is very cheap, from um, 35 USD to 75 USD. And second one is Odroid XU4. Um, this SBC has two CPU. One is Exynos Exynos 2 gigahertz CPU. The other is Cortex A3 CPU. So this SBC has 2 gigabyte DDR3 RAM, and you can select storage, eMMC or SD card. And this SBC has only gigabit Ethernet for networking. The price is 49 USD. And third one is LockPi 4. I remember maybe this SBC has tensor. I don't know the name. For machine learning.
Oh, TensorFlow.
Yes, TensorFlow things in this SBC. So you can develop machine learning stuff in this SBC, and this SBC has M2 SSD slot. So if you put M2 SSD in on this SBC, maybe your SBC speed is faster than eMMC or SD card. And this SBC also has gigabit Ethernet, Wi-Fi, and Bluetooth. The price is just 65 USD. And next one is Banana Pi M4.
Oh, you need to share your screen.
Oh. Okay, I'm sorry. The next one is Banana Pi M4. This is worse than previous three kind of SBC. This SBC has, but this SBC has 8 gigabyte eMMC, and this also has Ethernet, Wi-Fi, and Bluetooth for networking. The price is just 35 USD. The last one is this is long name. This SBC name is Tinkerboard. This board has RK3288 CPU and 2 gigabyte DDR3 RAM, and we can use only SD card for storage. And this SBC also has gigabit Ethernet, Wi-Fi, and Bluetooth. But this Tinkerboard is more expensive than others. Then if you for okay.
Skip the cameras.
Okay.
And
then if you buy camera SBC and your humanoid robot, you can connect like this. If your camera is USB type, you can connect camera to SBC using USB port. Then your process calculate image processing. Then you can send some message to humanoid robot, because every humanoid robot, remote control humanoid robot has UART port, because nowadays we use Bluetooth to control humanoid robot. Like if the company support remote controller, and humanoid robot. The controller and humanoid robot communicate using serial communication like Bluetooth, Zigbee, something like this. So you should connect UART port from SBC to humanoid robot, and then you can send some message like controller.
actually, then show the pictures of the cameras. Yeah.
Okay.
But don't need to say much about the cameras.
Okay. And I add three kind of cameras, like webcam, pipe camera, and stereo camera. But webcam and stereo camera is a little expensive more expensive than Pi camera. So if you use SBC, I recommend use Pi camera instead of webcam and stereo camera.
Okay, then let me just sit down quickly.
Okay, yeah.
Okay, so just to give you an idea, when we started out with humanoid robots, we actually also had a very cheap design. Where's your browser? How come the browser?
Just said no sound.
No sound. Okay, we'll try the sound in a second. Where's the browser?
Yeah.
Okay. Too big. So when we started humanoid robotics, one of our first designs was based on the Robotis Bioloid, which I actually thought was a very cool kit. It was very nice. You could build a lot of different robots with it. It was sort of like the Lego Mindstorms of humanoid robotics. And we developed several systems. Here's one of them. This is from RoboGames.
Outside of the research budget for most. I got you.
And let me just
Down, crawl on your knees, and have to stand up on the other side.
Now, during a competition, the owner can't be sitting there with a string.
No.
So then they're fully autonomous?
They're fully autonomous. They have to do all their own decisions.
So you can see a robot there and a better view here. Where's the video? So this is our Bioloid robot doing the basketball competition of Eurocup. And as you can see, at that time, 2007, you really didn't have the Raspberry Pi or the Odroid or any of the cheap SBCs that JSIC just mentioned. So for our robot designs, we actually used a mobile phone as the brain of the robot. The phone used infrared to communicate with the embedded microcontroller in order to control the motions. But this is actually a Nokia mobile phone here that we jailbroke, and then were able to install our own software and make it run the controller for our robot. At that point, that was the cheapest way to get enough sufficient processing power at a reasonable cost. I think just last week, Intel actually handed out or introduced a robot kit with wheels that is based on a mobile phone. But I think for humanoid robots in 2020, I don't think that actually makes sense anymore. Now with the Raspberry Pi and the Odroid, you can get good processing solutions for $50 or similar prices. And I think there are some drawbacks to getting your Android phone to talk to the robot reasonably fast. that makes it problematic. The phone is a good platform because you have a screen, it's easier to debug, you have some buttons you can click, but nowadays I wouldn't actually go down that road. I would just use a Raspberry Pi or something similar. Android, personally I like the Tinker boards as well, so I think that would be a better solution in 2020. So now, when we look at what Jill has for her robot, can you show them the central processing unit? So this is a small ARM-based microcontroller, I think, or an Atmega microcontroller. It's really just this big, and it's a small. You have to switch the camera.
Maybe this board has
ESP32, okay. Yeah. There are several processor families that people have, but this is all that we read that comes with the Robo Hero Thunder Tiger. That is enough to control the motion and the motors, but it doesn't have any camera, no vision system per se. You have to come up with a different solution. So in our case, for example, what you can do is you can have your Raspberry Pi talk to this board and control the motion. That would be a reasonably good design. Or you can have your Android phone talk to this and control the motions. As far as processing power is concerned, you can get a lot of work done with 1 gigahertz, 1.5 gigahertz processor is easily fast enough. As long as your vision system runs at about 10 frames per second, I think it's good enough for most Eurocup events. It would have to be a very highly dynamic soccer match or something that you would look at this as a limiting factor. Usually it's your robot walking into the wall that's a problem, not because it cannot see the wall fast enough that it showed up. Okay, good. Yeah.
Yes.
So this gives you full control over the vision processing, the algorithms that you're running. It's the preferred solution if you actually want to do research on applied computer vision or theoretical computer vision. However, it does make the robot more expensive. You do need to have some processing. It also adds a bit of weight. Those Raspberry Pi require more power, so you need to have a bigger battery. So it slows down your robot. So your robot is not as dynamic anymore as if you just had a microcontroller on it. I think that's the other thing that people realize. Yeah. So go ahead, JC.
Okay. Okay. Next, my third method, using remote control humanoid robot with intelligent camera module. I will introduce some intelligent camera modules. If you use these camera modules, you can detect object very easily because you don't need to do image processing programming like using OpenCV. This camera module, if you just click or you just drag and drop, and then you can detect some objects using this camera modules. So very easy way to participate in intelligent humanoid robot competition. The first one is Husky Ranch. This is the newest intelligent camera module. This camera module has I don't know the pronunciation, Kendrite K2 210. This CPU has machine learning stuff. So this CPU calculate machine learning like Intel, Movidius, or Google TPU, something like this. So this camera resolution is very good, like 1632 by 1232, and current consumption is very low, like 320 milliampere at 3.3 volt, and this camera module has two type of interface, connection interface, such as UART and I2C. So if your main controller has UART and I2C, you can connect your main controller and this camera module. And this camera module has many built-in algorithms like face detection, object tracking, object recognition, color recognition, and tag recognition. And the price is very cheap, just 45 USD. Second one is Pixie. Carnegie Mellon University is developing this camera module. The camera module name is Pixie 2, but resolution is not good, just 316 by 200 like this. And current consumption is also good, like 140 milliampere at 5 volt. And this camera module has a lot of interface, connection interface, like I2C, UART, SPI, USB, digital, and analog. But this camera module has only three built-in algorithm: color detection, line tracking, and barcode recognition. The price is 60 USD. And the last one is OpenMV Cam H7. You can develop this camera module using Python. They support their IDE, and then you can add your function. You can add your stuff, your image processing stuff in this program, in this IDE, and this camera resolution is good, about 640 by 480, and the FPS is maybe 60 FPS at this resolution. This camera also, this camera is also good current consumption, and connection interface is I2C, UART, SPI CAN, USB Wi-Fi. But if you want to use Wi-Fi, you have to buy extension board. And I explained this camera. You can use Python programming, so you can develop your programming, like this camera support OpenCV, so you can add many functions from OpenCV, so you can detect camera color recognition, marker tracking, face detection, eye tracking, person detection, optical flow, QR code detection, something like this. The price is 65 USD. How to connect this camera to humanoid robot? I think we have two methods. The first method is we can connect this camera to humanoid robot directly. But in this case, you have to do firmware programming in humanoid robot. So this means the company support open source for humanoid robot, and then you have to program firmware program for camera module. But I think this is very difficult, so I recommend method 2, because every intelligent camera module support Arduino library. So if you use Arduino board between camera module and humanoid robot, you can use this camera module very easily. This means you can use their Arduino library to get object. If you detect some object from camera module, and then camera module send some protocol, some message to Arduino like XYZ and with height, something like this, and then your Arduino can send some message to humanoid robot like a second method. In this case, if you use Arduino Nano or Pro Mini or Uno like this, this Arduino voltage level is 5 volt. But I explained to you many nowadays humanoid robot has Bluetooth communication module. So many humanoid robot has 3.3 volt MCU, so you have to use level shifter to communicate Arduino to humanoid robot. This is our humanoid robot using Pixie and Arduino Nano. Okay, I can show you this video. Okay, change browser. We developed this camera module for Eurocup Junior teams.
So I have to admit I'm not such a big fan of the intelligent camera modules. As long as you have the right algorithm in the module, of course it's great. It's much easier. But even you may not have enough calibration parameters that are accessible. And I think I'd rather be able to implement my own computer vision algorithm. Especially at the beginning, when we started the Eurocup competition, a lot of the events were done in a colored environment, so you had to look for red and green and blue. But nowadays, for the Eurocup competition in the marathon now, you have to recognize the markers. And I think only the Husky lens may be able to detect the markers correctly. I don't think the other ones could. And you may have also other problems. Like one year when we were in Sydney, we had a problem with our vision algorithm where the detection wasn't working when the ball was close or the ball was far away. So what we had to do is use two different sets of parameters. On the top part of the image, use this set of parameters. On the bottom part of the image, use another set of parameters. A lot of those boards don't support that kind of processing. So since vision is the only sensor, the most important sensor for our robots, I think it's better to have a Raspberry Pi with a webcam. But of course, it is more work to actually implement the vision processing then. So if what you're trying to do matches exactly what the intelligent camera can do, then it's a very elegant, very attractive solution. But if you want to move it outside of what the camera can do, then of course you won't be able to extend it. Whereas if you have a solution with an SBC and a webcam, then you can always implement a smarter algorithm. Okay, next. So now, so far, we've looked at the humanoid robots and the robots that you can buy. Now we'll start a little bit talking about how to build your own. Now, a lot of people think building your own will greatly reduce the cost of the robot. In my experience, it will actually make it more expensive because costs like the servo motors, if you buy 20 of them, you get them cheaper than if you buy just 10 of them. Or if Robotics buys 100,000 motors, then they get a better price than you. So I do prefer to build my own humanoid robots, but not because of the cost. I think the cost, usually they end up a little bit more expensive than what you can buy, but just the fact that the students learn a lot more by building their own humanoid robots. It's a great journey of discovery to build your own humanoid robots, but I think it would not be reasonable to expect to build your own humanoid robot and be able to construct OP3 for $1,000 then or something like that. That's just not possible. If you build your own OP3, by the time you're all finished, not taking the time for design into consideration, you end up with a price that's pretty much in the same ballpark. So go ahead, please.
Okay, the last section is building humanoid robot. To build humanoid robot, we should consider many things, but we are. I will explain. You are beginner, so I think if we consider only board, control board, and motor, that's it. I think. So I will explain just control board and motor first. Then I will introduce some structures for humanoid robot. When I was developing humanoid robot for the first time, I used a microcontroller unit. This means at that time we usually use AVR because AVR has ROM and RAM on one chip. So this is very good chip at that time. So I use this. But if you want to use this stuff, you need ISP or JTAG something like this to upload your program. So and second board is Arduino. Arduino is very easy, very good control board because Arduino support many kind of libraries like control servo motor, communication, serial communication, how to use Bluetooth, how to control button or LED, something like this. So I recommend this to control your humanoid robot. And then the last one is SBC. I explained Raspberry Pi, Tinkerboard, Banana Pi, Latte Panda, LaPi, and so on. And if you have enough money, enough budget, I recommend Intel NUC or Jetson series. This is a very good performance control board. Our humanoid robot has Intel NUC and Jetson Xavier, something like this. And I explained RC server and smart actuator. Then this is very commonly used structure for humanoid robot. Left picture is standard kinematics. This means you can see legs. Each leg has 6 degrees of freedom. Ankle, knee, and hip. Hip joint has motor actuators, but if you go to a right picture, you can see parallel kinematics. This kinematic structure, if you use this structure, can use only 5 actuator in each legs. So if you don't have enough money, you can design like this because you don't need to buy 16 actuator for your robot. You can buy just 14 or 16, something like this. Yep. And you can add joints like torso yaw, pitch roll, and elbow yaw, and grippers. And then if you decide your control board and actuator, and then you will design your humanoid robot. And I recommend some CAD tools, Tinkercad, Blender, FreeCAD, and AutoCAD is free for students. So I recommend these tools. Yeah, and I will.
Okay, good. So the kinematics, you need to think about the kinematics. The parallel kinematics or the standard kinematics are the two options. Parallel kinematics is nice for walking. It makes a couple of things easier, but it limits the kind of motions that your robot can do. But if you're only interested in walking, then it's a good choice. The other one usually also works. It also depends on how much torque you have in your servo motors. Parallel kinematics, you don't need a servo motor in the knee joint usually, so then that makes it a little bit lighter. But it's also the construction is a little bit harder. Now, once you actually decide on the design that you want, then there's two possible ways of building the frames. Nowadays, 3D printing is very popular. If you build a small humanoid robot, the standard processes for 3D printing, the ones that are commonly available, are easily good enough to build a frame for the humanoid robot. My friend Mike Overstreet, he built a 3D printed Darwin robot. For me personally, for the larger humanoid robots, 3D printing is either not strong enough or more expensive. Of course, if you use fancy materials for your additive manufacturing, like titanium, nylon mixtures and things like that, then you can build very strong parts, but you won't be able to print those on your $100 desktop 3D printer. You need an industrial strength 3D printer, and I think for those kind of humanoid robots, I think a CNC machine would be more useful. Like for us, I think JSIG would also prefer a CNC machine over a 3D printer if we had the choice. But for a small humanoid robot, yes, you can get a lot of mileage out of being able to produce parts using that design process. And what Jill has been doing so far for today, she can just show you, because basically she is using a kit, but it's a very simple kit. So what have you been doing for the last hour, Jill?
Yes.
Yeah.
And,
Just go talk to them.
uh,
So basically, the first thing you need to do is for the robots, she attached the heads and needed to calibrate the home position to make sure that if you tell the robot to go to 0 degrees, you need to know if that means the arm is like this or like this or like this.
and I did it all wrong.
And this is the sort of thing. Don't worry, my students do it wrong all the time.
Mm-hmm.
It's one of the simple things to forget about and get wrong, and then you worry why your robot cannot walk. It's also things that need to be rechecked once in a while, because sometimes we replace a motor and we're not quite careful enough when we calibrate for home position, and then the walking gait is slightly off, and it gets worse over time as the servo motors wear out. One other issue that we haven't discussed yet is the power source. So your robot needs to be powered, right? And that again can be quite expensive. If you go, you can bring some of the batteries that we use for our humanoid robot. And Jill, you can just show your battery to the people. It's different sizes. Like what we have on the table there. Okay, show it to the camera. So this would be a very simple one. A low capacity battery, 500 milliamp hours. Nowadays, most of the batteries are lithium polymer batteries. And the voltage range is about, depending on, it's usually multiples of 3.7 volts, because each lithium polymer cell has 3.7. So if you can stack them up in series, then you can get 7.2 volts or 10.9, 14.1. Yeah, 7.2. So next one should be 10.9, right?
Oh,
3.6, not 3.7.
3.7.
Should be 3.7.
This is not beautiful.
No? LTO? Okay, we're not sure what kind of battery this is, but it should be 3.7 per cell usually, and then you end up 14.4 is one. Now the more voltage you have, the more power you can get to the motors usually, the higher they can run. The RC servos that we mentioned, it's also important to note that they actually usually have a maximum voltage of 6.2 volts, at least the cheap ones, which means that you really can only use a battery with 7 volts. Here are some of the other batteries that we use on our humanoid robots. So this is a 11.1 volt lithium polymer battery that we use for the OP3 robots. How much milliamp hours did this have?
1,800.
1,800 milliamp hours. This one, 2,200, is a bigger extended battery for the OP3. Also 11.1 volts. And these are the batteries that we use for our middle-sized 80 centimeter tall humanoid robot. 5,000 milliamp hours. And what voltage do we run on those?
14.
4 cells. So
14.4.
14.4. 14.8.
4.
This is also, yes, and also about 5,000. They of course get heavier and heavier. This is the battery for the Thormang OP, for the Thormang robot. So it's 22.2 volts. For the motor part, 22,000 milliamp hours. Now, the heavier your battery is, the more difficult it will be to build the robot, the more torque you need in your servo joints. And, but of course, the longer your robot can run. So with a battery like this, 550 milliamp hours, a very light robot will be able to walk maybe 10-15 minutes. Our OP3s with the extended batteries are about 20 to 30 minutes. I don't know if we ever ran over Binion all the way. for a long time. Maybe 40 minutes.
Maybe.
Maybe, yeah. It's a problem with with the robots. We always wish we would have better batteries, more powerful batteries. They also deteriorate very quickly, and you have to be careful. Sometimes when your robot falls down and smashes one of the cells, that actually becomes a fire hazard. So in the last 3 years, pretty much for FIRA competition, we have 1,200 participants, hundreds and hundreds of robots and batteries, and basically every year somebody catches fire, right? So you have to be careful with those lithium polymers. We also had labs destroyed. Some of our colleagues had bad luck charging the batteries overnight, and then the battery caught fire. So you cannot take safety. You have to take safety seriously with those batteries. So we don't charge them overnight usually, just for that reason. Okay, good. So Jill is calibrating all the home positions for the servo motors, and she will finish that in a little while. Thank you very much for watching the first session of our humanoid workshop. Next week, again on Wednesday at 3 o'clock, we'll continue and look at finishing building the humanoid robot that Jill is working on at the moment. And of course, to all the new teams that want to join, I think for Eurocup, with $300, I would probably focus on the triple jump. I think that also, because not only do you want to take part in the competition, of course, it's also important to have a research purpose, to be able to make some contribution. And the kind of design with a light battery and a microcontroller that allows you very fine control for synchronizing the motions of your robot. You can actually do some interesting work in the triple jump competition, even if you just have a very simple vision system or no vision system. And then, of course, you can also take part in the sprint competition. That is also one of the events that you could join, even with a very minimal robot design. I don't want to say it's simple. It's not simple to build a good humanoid robot. Having $10,000 doesn't make that part any easier, or $300. It just gives you more possibilities, more things that you want to do with your humanoid robot if you actually have an OP3. But even with a robot that you build yourself, for the triple jump, for example, you can keep the cost down, but not having fully articulated arms. Maybe just have two stiff arms would be enough. For the sprint, that would be enough as well. You just wouldn't be able to do the basketball and events like that. Weightlifting wouldn't be possible, most likely. So I hope that gave you some ideas for the landscape, different materials, components, technology that is available to get you started in humanoid robots. And then we will continue the workshop series next week with a little bit more on construction and also the background that you need academically in order to get started in humanoid robotics. Okay, so thank you. Bye-bye. Bye-bye. Bye-bye.